Okay, and we're moving on with lesson 2.2, and this is where we finally start graphing the polynomial functions. Remember, one of the objectives is to graph the polynomial functions. We've gone through a lot of information to help us do this, and we're going to put this all together to help us just draw a rough sketch of this so we know what the polynomial looks like before we ever touch technology and try to graph them. Now, the first one, they're very kind. They already have it in factored form for us, so we go through this and we try to figure out, apply the leading term test. Well, when it's in factored form, it's a little bit hard to find the leading term test, but here's what we can do. All we need to do is multiply our leading terms in each of these monomials, or each of these binomials. So what I really need to do is take the negative 2x times this x times this 3x cubed. All I need to worry about are those first numbers in each of these to find the leading term, because if you think about your distributive property, you would have to distribute your 2x to this, so you get a negative 2x squared, then minus 4x. Then you'd have to take these and multiply them times the 3x minus 1, which was cubed. Well, this cubing has to be done before you can ever multiply it by that, but eventually you're going to have a 3x minus 1 times another 3x minus 1 times another 3x minus 1, and eventually all these 3x's are going to get multiplied together, so you're going to have a 27x cubed. Okay, so here's what I'm getting at. There's really no reason to go through the whole multiplication process to find your leading term. Your leading term is simply the product of this negative 2x times the x times the 3x cubed, because it's outside that cube. So it's negative 2x times the x times the 3x cubed. So that's a negative 2 times x squared times our 27x cubed. Now we're going to multiply these together. It's a negative 54x to the fifth. Now this is a leading term, and we're going to use that in our leading term test. A couple of things that we pick up. First of all, our leading term, or leading coefficient, is negative. When it's negative, it tells us something about the shape of our graph, and when it's positive. So first thing I want to pick up is a fifth-degree polynomial. Keep in your mind what fifth-degree polynomials, they're S-shaped that come up through the origin, and they have opposite end behavior. But because this is a negative, it means instead of going from low to high, it's got to go from high to low. So that's one of the things that we know from our leading term test. We know that it's got opposite end behavior, that it's going to come from high to low. So the general shape of my graph has to be like that. So that's one thing. Next thing, they want us to determine the zeros and state multiplicity of any repeated zeros. So clear that off for a second. What are the zeros? Since it's already in factored form, they've been very kind to us by allowing us to just pick off the zeros. And one of the zeros is at 0. The other 0 is at 4. And this one might require a little bit more work, because what do I put in for x to create this factor's value of 0? I don't have to worry about the multiplicity, because once I get the value of 0, cubing it's not going to do anything to it. So I just have to figure out where 3x minus 1 is equal to 0. So that means 3x is equal to 1, which means x is equal to 1/3. Now 1/3 is another one of our zeros of the function. And if you quick mentally did that, if you took 3 times 1/3, a third of 3 is 1, and 1 minus 1 is 0, and 0 cubed is still 0, so that is one of our zeros. So we have zeros from our leading term test. We know that it goes from high to low. And then what else we need? We need a few additional points in the graph of the function. We aren't going to grab any additional points. If you can get this information for me along with the multiplicity, I guess that's the one thing I didn't really point out here, because this one is to the first power, this one's to the first power. It's going to cross at 0. It's going to cross at 4. This is odd, so it's still going to cross, but it has to flatten at 1/3. So a real rough rudimentary sketch on this thing would go as such. I know the graph is coming from high and finishing low. The next thing I know is it crosses at 0, it crosses at 4, so if I call that 4, it also crosses at 1/3. I'm not going to get all uptight about the scaling on this at all for you guys. I just want to make sure you have a general idea of what the shape is. So it's a fifth-degree polynomial that's coming from high to low. It's got to cross at 0, it's got to cross at 4, but it's got to flatten and cross at 1/3. So here it comes. It's going to come down through, and it's going to cross at 0. then it's going to come back up, it's going to flatten at 1/3, then come back up, it's going to cross through the x-axis, it just flattens and crosses, and then comes back down through 4. Obviously, a little better sketch would be kind of nice, so here's what I'm thinking I should probably do. I got to cross through here, I got to flatten through here, then that can come up. I don't care about how high that graph goes, I'm just concerned that you know it's going to come back down and finish with a negative, and this is going to come back up and finish high. So crossing, crossing and flatten, crossing, there's our sketch of our curve. Polynomial graphs, putting in multiplicity of zeros with their high to low and their leading term characteristics. So next one, they weren't quite as kind, they didn't give it to us in factored form, but when it's not in factored form, we get our leading term test very easily. So our leading term is cubed. As soon as I see cubed, I know it has to have an S shape. The next thing I look at, it's negative, so okay, that means it's got to be a reflection across the x-axis, so now it's going to be more the shape of the black graph. So it really isn't the red graph it's going to be, okay, craziness on that part, it's going to be more like the black graph. Okay, so leading term test. We know the end behavior and we know the general shape of the graph. It's predominantly a cubic graph going from high to low. Next thing, we need to determine the zeros. So to determine the zeros, this time we're going to have to factor because they didn't have it factored. Plus 2x squared plus 8x. The only thing that we're able to factor out of here, it would be a negative x. I prefer not to have to factor a leading term that is negative in my binomial, so I'm going to take out a negative x, which will change all these signs, and I factor out an x. So it's x squared minus 2, x plus, I'm going to correct that, 2x minus 8. So all the signs had to change. I'm just verifying that they did. I pulled out an x. Next thing I want to do is try to factor this 8. And the x squared minus 2x minus 8. So 0 equals negative x times x squared minus 4, x plus minus 4, x plus 2. That is the correct factorization of this, so now I should be able to figure out what the zeros are. The fact that this is negative is still just telling me it's coming from high to low. One of our zeros are when x equals 0. Another 0 is when x is a 4, and another 0 is when x is a negative 2. Okay, so now we're going to fancy this graph up a little bit. I had the general idea. We're going to draw an x and a y-axis. Here's what I care about. You better know where it's crossing the x-axis. It's crossing at 0, it's crossing at a negative 2, and it's crossing at a positive 4. Right now, how is it crossing? None of these have any multiplicity. They're all the powers of 1, so it just means it's crossing. Because it was negative, we've already established it's coming from high to low, so our graph is coming from high, it's going to cross. Coming back through 0 is going to cross, and it's coming back through 4, it's crossing. It's not going to flatten because none of those have a multiplicity on their factors. And that's how we're going to graph polynomial functions, and using our leading term test, doing our factoring to find our zeros. If there's multiplicity, whether it's tangent or whether it crosses and flattens, those are the main concepts that you'll be responsible for and able to create a very rudimentary graph as the one I've done here. So we're finished with the graphing of the polynomials and hopefully our polynomial discussion.